Multiple decrement model. In a multiple decrement model, there will be more than one way of exiting the policy. You can start from state 0 and go to state 1, state 2, state 3. For example, you are starting with state 0, which is alive, and then from state 0 can go to state 1, which is withdrawal, and goes to state 2, which is retirement, and then can go to state 3, which is death. The rate of transitions from state 0 to state 1, we can say that it is mu x plus t 1, or sometimes we label it as mu x plus t 0 1, which is from state 0 to state 1, mu x plus t 0 2, mu x plus t 0 3. The force of decrements mu x plus t is also known as the instantaneous rate of transition, transiting from one state to another state. In general, we can write probability of future lifetime tx in between t plus dt for any cos jx equals to j, given that future lifetime is greater than t, is equals to dt qx plus t j, which is also equals to mu x plus t j dt. This is similar to what we have seen in the previous video, which was the single decrement video. So we can say that mu x plus t j is also equals to limit from h equals h to 0, probability of tx is in between t and dt, t plus dt, for any cos j equals to limit h approaching 0 h qx plus t j over h. Given that this one is OH function, if in any decrement functions, you are going to get h qx plus t j equals to mu x plus t j times with h plus OH. If you have two decrement, then you are going to get h qx plus t 1 equals to mu x plus t 1 times with h plus OH, and h qx plus t 2 equals to mu x plus t 2 times with h plus with OH. These two OH are not similar. We also know that in the double decrement cases, the force of mortality mu x plus t tau, the total force of mortality equals to mu x plus t 1 plus mu x plus t 2, and then the occupancy probability which is probability of x to remain in state 0 is tpx tau. And then the transitions probability for this case would be for double decrement case, we are going to have tqx1 equals to 0 to t s px tau mu x plus s ds, or tqx2 equals to 0 to t s px tau mu x plus s 2 ds. This is 1. There are two types of multiple decrement model. One is reversible and another one is irreversible. The most common irreversible case would be the models that I've showed you just now, which is this model. And the second one would be the permanent disability model. In the permanent disability model, I'll write it irreversible model, permanent disability model. In permanent disability model, usually policyholder will start subscribing when they are healthy, and then somewhere in the near future things happens and then they become permanently disabled. There is no way for the policyholder to go back to healthy, so we call it permanently disabled. Or from healthy can go directly to state 2, which is death. The rate of going to state 1 would be mu x plus t 0 1. Here would be mu x plus t 0 2. And the policyholder also can go from permanently disabled to death, which is mu x plus t 1 2. You see, the arrows only go one way. Now let's look at reversible model. In the reversible model, the most common reversible model is disability income model. For disability income model, usually the policyholder will subscribe the policy when they are healthy, which is state 0, and then from state 0 goes to state 1 when the policyholder become disabled, or can go to state 2 where the policyholder died. When the policyholder become disabled, there is chances that the policyholder can come back to healthy. So you can see that the arrow goes to disabled and then there's a return arrows to healthy. That's why this is called reversible. The rate of transitions from 0 to 1 would be mu x plus t 0 1. The rate of transitions from disabled to healthy is mu x plus t 1 0. I will rewrite this again, 1 0, and here mu x plus t 0 2, and from disabled to death it would be mu x plus t 1 2. Okay, that's it for this video. Thank you.